Yeah.
Okay, great. Okay, so my name is Jeff Nelson. So my project, I called it Dialect Bridge. So it's a translation between a dialect and a standard language. And so it's my capstone for CS 687. And my advisor was Mr. Kim. Okay. And Dr. Sam suggested we do some kind of a graphic, so I had an AI generate this. So this is a German-style mountaineering hat with the two flags. So I'm going to be translating between Austrian dialect and standard German. So that's what this is all about with an appropriate background from Seattle. So, um, so our typical, yeah, I'm going to let you know what the problem is, the motivation for doing something about it, background related work, how I approach the problem, and what kind of data I collected and what we can learn from it. So the kind of our standard process here. So um, Viennese dialect is the language spoken in Vienna, Austria, and it's known as Wienerisch, and it has limited natural language processing support. It's what we call a low resource language. And there are few publicly available translation tools or applications for it. So that's kind of really the problem with that. And dialects in general are are underrepresented in the natural language processing field. So it's a problem not just for Vienish, but for other things as well. And one of the challenges is the limited data sets. So the limited, what we call corpora, they're hard to come by for those kind of languages. So that's one of the challenges that's faced with that. So my motivation was that dialects are an important part of cultural identity for people worldwide, not just in Austria. And so it was interesting to try to find some solution there. Blaschke and team informed us that dialect speakers want tools that accept dialect as input. So they don't really need translation tools because they speak standard German in Austria as well. They just want something that can accept their input, the input as dialect. For instance, maybe Google Maps or Siri, something like that, that would that could accept what they speak every day. And so that's really the challenge for them. And if there are tools that can accept dialect as an input, that would improve accessibility for these speakers and others around the world as well. And these underrepresented dialects in low resource languages really do deserve better NLP support. So that was part of my motivation for this project. So part of the background is, so there's the map. If you don't know where Austria is, it's in Western Europe, and you can see it's surrounded by some well-known countries there. But according to Fiore and his team, the transformer-based LLMs, large language models, perform best with large corpora. And we've heard stories like that. They might need thousands to millions to even billions of data points, and that's kind of what they need to learn from. Um, but we've also learned from Kanekam and others that dialects typically are often characterized by limited corpora. So they really don't have these large data sets that are needed for large language models. Also, there's a challenge of non-standard grammar and spelling that dialects often have. So some of the large language models really struggle with those kind of things. And then Browning team, however, report that few shot prompting. So few shot means giving just a few examples, like literally 4 or 5 examples to the LLM, can help it to learn from a few in context examples. In this case, it would be some examples of the Wiener dialect, and they can learn from that. So there's hope and optimism in the industry about that. So in the related work, Keesley and Brown and Blaschke really provided some really key things. So in essence, the key themes that we see with these sources are that there is a need for dialect-friendly tools and applications. LLMs are starting to show promise for dialects, the current ones that are trained on natural languages, and also those that are trained, the few shot prompting really is showing some effectiveness in terms of working with the small corpora or the small data sets. So that's one way of overcoming that challenge. So the approach we had is that I created a data set. I call it the gold set, and this was 158 sentences from various sources. I used my own knowledge of both languages, um, guidebooks that talk about Austrian dialect, and also AI to help create this set. Um, and then I had native speakers, two people in Vienna, Austria, review and correct this data set. And from that, then subsets were used for training and testing. So the first method is called a rule-based translation method, and that's basically an older style direct substitution of words. The second method was an LLM with a few shot prompting. And we'll go over into those in more detail. And then I used some well-known metrics that are used in the machine translation world to determine the quality. And these were automated uh, metric systems that I was able to use through a Python script as well. So the three main ones here, one is BLEU, and basically it looks at word overlap. So one word in one language translate to the other, how similar are they? It's an older style one, but it's still kind of the standard that was used for many, many years. So a newer one is called chrF. That one looks more at the character level rather than the word level to see the similarities. So we get better quality, especially in terms of dialects, because it's not looking at the entire word, but kind of segments of the word, which can be helpful, especially with the non-standard spelling and so forth. And then COMET is a quite new one. This became available in 2024, and it actually looks at the semantic meaning of phrases and sentences. And it's an LLM neural based system as well that provides really quite good results. So the design of the system, as I mentioned, we have the gold set, which is our primary corpus. The rule-based methods, we call it lexical substitution. Basically, this word means this word in the other language, but you have to give it all the rules very explicitly. So I had a JSON file that had those words and phrases. So, and then the LLM method, I used the Llama 3.18b instruct from Meta and with few shot prompting. So those were the two methods, and then I combined captured those outputs, translation outputs, and then used the quality metrics to see how well they did. So the implementation, as I mentioned, the rule-based system, I had a JSON file mapping of 15 phrases and 87 words. So basically a bunch of Wienerish phrases and words, and then what those would be translated into standard High German. And so it would literally be like a dictionary lookup. So that and I used some light text normalization for data cleaning, but it really didn't need a lot because the gold set was curated in quite good shape. The the thing about the rule-based system is though it's very inflexible. It doesn't learn. It's just word for word substitution. So with the LLM, the Llama 3.18b Instruct, it's a transformer type neural network. So it can work in parallel words at the same time. It can generalize on phrases and sentences. And this particular model was actually trained on natural languages. So it was a really good fit for this project. And it became available in 2024. So I did some fine tuning with the temperature, which means how creative do you want it to be? And in translations, you don't want it to be creative, but if you're writing poetry, you do. So I kept that small. And then 100 tokens means how many words is it outputting? So with small groups, 100 is fine. I had to increase it to 500 for larger sets. And so the few shot prompting, I literally just had 5 examples of the translations and put that in. And then you also, when it says instruct for the Llama, it means you can actually tell it what to do in English. So I said, you are a translator. Your job here is to translate from Viennese dialect into High German. And so that's what it did, and it understands what you want it to do. And then I used a Hugging Face API, so this worked really well. It gave me access to the LLM remotely. I didn't have to have it used locally and access it, let it do the processing, receive the translations back worked really well. And it's the API was called an inference, which means that the LLM was already pre-trained, and we're not training it. We're literally prompting it to help it see some new rules, so to speak, but it's not, you're not training it. And it has a very friendly API for Python, so it worked out really well. So the data collection,
Excuse me, you
Mhm.
have 5 more minutes.
Okay.
Thank you.
So basically, as I mentioned, took the 158 native reviewed sentence pairs, took the translation output, put it into Excel, and then fed that into the quality measurements. And this chart below, you can see this is how I captured the information. I had the ID, the linguistic category, the input, the translation, and then what each one provided. And then that was in a CSV file that I sent to the translation. So in the analysis here, the important thing is that if you can see by these numbers in the top, on the BLEU, chrF, and COMET, both rule-based and LLM methods did very well. You can see they're in the good to very good range, and these are the ranges given by those that create these metrics. So it did very well on both of them. However, the LLM always scored higher, on average about 8% higher. And so it was very successful. And then for the gold set, basically almost 80% of the sentences that I gave to the reviewers, they changed. So that goes to show how important it is to have humans in the loop, we call it, reviewing the information. The native speaker review was really important for quality. So the findings were that native speakers really improved the corpus quality greatly by changing 80%. The rule-based method performed well. The LLM performed even better. And one example here is you can see this term, it's a called Phoebe. It's basically saying goodbye, but the rule-based did it formally and the LLM did it informally. So I thought that was an interesting comparison. So conclusions, there's an underrepresentation of dialects in natural language processing, but the Dialect Bridge project showed that there are viable solutions available today. One's more legacy, one's more current. Human review is very important for quality, and small data sets can support translation systems. So the project was constrained by a lack of a large data set, diversity of LLMs. I just used one, only translating in one direction and a single development environment. So future work, I would do additional dialects, um, other corpora, additional language models in different tuning options and bidirectional translation. So here's my demo. Okay, and there's just some of the key references I found for this project, and time for any questions.
Does anyone have questions?
Jonathan.
Excuse me. Hey Jeff, this is a super cool project. It was great that I was able to see it. When you were talking about working with the Austrian dialect, I was wondering, and I don't know if you had thought about this at all, but is this something that you can apply to like people that might be speaking with some sort of disability that you could almost customize a translation or an LLM to kind of like accommodate something along those lines as well as dialects?
That's a great question, and I think so because I, I mean with the LLM based method, I mean it generalizes on natural languages and it learns well, and even with a little bit of prompting, you could train it, not train it, I just prompt it to kind of consider some new things. Like for example, this LLM that I use had never seen Austrian dialect before, I'm pretty sure, but it still did quite well with it. So I think the general principles would work outside of just a standard language. Because the whole point is like dialects just aren't the same as a standard language. So anything that's different from the norm would be something that would be a target for this kind of application. But I think that's a really great idea, and that could really broaden it into some really useful things. So thank you.
Yeah, yeah, and then just out of curiosity, I'm not sure um did the work that you do to expand the into the dialect it, like because you used natural language processing to do that, is there like in terms of like the actual amount of space like a data that you need, is that can you also do that just from kind of like extending the context of the LLM like insert in your session,
Mhm.
or is it something that you need to add on top of that?
Well, one of the things I looked at, and this would be kind of for future work, there's a really large data set. It has actually 1 million entries of people. It's basically online comments to a newspaper, and so I just for experimental purposes, I was able to get access to it, and I was able to grab the information and do some basic, processing of it. So, yeah, I think you could easily expand it into much larger data sets. It's just they're hard to find is the biggest problem, but it would work fine with that, I think.
Okay, cool. Yeah, thanks so much. That's an awesome project.
Thanks, Jonathan. Great to see you.
Okay, thank you so much. Does anyone else have a question? If not, we can close our section 6 at here. Thank you so much for presenting your projects today.